Welcome to our YouTube channel Incredible Maths. In this video we will see a definition in abstract algebra, that is the definition of group and examples. So first let us see the definition of group. So group is an algebraic structure with single binary operation. So now let us see what is meant by algebraic structure. So algebraic structure is nothing but a set with one or more binary operation. So the operation operating on two elements, so that operation we call as binary operation. So the definition of group, so the group we denote by G, a non-empty set. So here the set considers non-empty. Suppose if a set is empty, then it will obviously satisfy all the properties. Therefore, we consider a non-empty set. A non-empty set G together with the binary operation star defined on G is said to be a group. If for every A, B, C in G, the following conditions are satisfied. So next let us see what are the conditions. So the first condition, so we already mentioned that, so for every A, B, C in G, so we have A star B in G. So this property we call it as closure property. If for every A comma B in G, suppose if we have A star B in G, then we say that G is closed under the operation star. The second property, A star B star C, this is equal to A star B star C. So this would be satisfied for every A, B, C in G. This property we call it as associative property. The third one, A star E equal to E star A equal to A. So this would be satisfied for every A in G. Here E is the, where we call E as the identity element of G, and this property is called identity property. And the fourth one is A star B equal to B star A equal to E. So already we saw that E is the identity element of G. So what about B? B is the, if this property is satisfied, then we called B is the inverse of A. So this property is called inverse property. Here for every A in G, there exists B in G such that A star B equal to B star A equal to E. So G together with the binary operation star, if it satisfies these four properties, we call G comma star is a group. So if all these properties are satisfied, then we call this G comma star is a group. So star is a binary operation. So star is a function from G cross G to G. Suppose if star is a binary operation, then automatically the closure property will be satisfied. So now next let us see some examples of group. So examples. The first example, set of all integers under the operation addition is a group. So here, so when we add two integers, so the result will also be an integer, therefore the closure property will be satisfied and associative property will be satisfied, since sum of three integers will be an integer, and the answer will be equal, the left hand side will be equal to right hand side, and the property 2. And third property is identity property. So here 0 is the identity element. 0 is the identity element, and the inverse, suppose if A is an element, inverse of A will be minus A. For every element A, the inverse will be minus A. So therefore G comma plus or G set of all integers under the operation addition is a group. And second example, so we can take Q comma plus set of all rational numbers together with the operation addition is a group. So here also 0 is the identity element and inverse of A will be minus A. And sum of two rational numbers will be a rational number. Okay, so we will see in detail. Sum of two rational numbers will be a rational number, therefore closure property is satisfied. And the second one, A plus B plus C will be equal to A plus B plus C, since star plus is associative. And third property, existence of identity element. So here A plus 0 equal to 0 plus A equal to A. So this 0 is called identity element. And fourth one, A minus A equal to minus A plus A equal to 0. So this 0 is the identity element and this minus A is the inverse of A, or specifically we can call it as additive inverse of A. So we can see some more examples. Real numbers under the operation addition is a group, and set of all complex numbers under the operation addition is a group. So here identity element is 0 and inverse of A is minus A. So here also identity element is 0 and inverse of Z is minus Z. So next we will see some of the examples which is not a group. Okay, so let us see this example. So natural numbers together with the operation addition. So this is not a group, because so here the identity element, so E will be 0, so because 0 is the only element which satisfies that property. So A plus E equal to E plus A equal to A. So when we take E plus A plus E equal to A, so we will get E equal to 0. So but E equal to 0 does not belongs to n, so therefore, so this implies identity element does not exist. Okay, and also the inverse property is also not satisfied. Okay, so for every A in n, so minus A, so will not be in n. So inverse property also fails. So therefore the conclusion is n comma plus is not a group. Okay, and similarly, so n comma minus is also not a group. So now we can check whether this q comma minus r comma minus is a group. Check whether this q comma minus r comma minus is a group. So you can work out and check. So post your answers in the comment box. So we will discuss in the next video. Thank you.